We're going to do a couple of lightning talks here. So our first one is Alan Hannon. He's talking about securing physical access. Thanks.
Good afternoon, everybody. My name is Alan Hannon. Thank you very much for being here. Thanks also to the program committee, as well as all the NANOG members for having me here to talk. I timed it earlier, it's about 5 minutes. Hopefully I'll be brief. For some of you that work in Fortune 500 companies or work in other areas, your executives think it's a great idea to move to the public cloud. In a couple of years, they're going to decide that was a terrible idea and ask you to move stuff out of the public cloud into a data center. There's a couple of things that we've learned in that process that I thought I'd share with you guys, as well as some other learnings about some good habits to do when it comes to physical security. I work for a computer security company called CrowdStrike. Been there about 4 years. I see things every day that just scare the heck out of me. It's really hard to be safe, but it's pretty easy to be safer. So I'm going to walk through a few things we think about. The target audience here really is not for your traditional telco or ISP. It's not really targeted at folks that run their own physical plants or run their own physical data centers. Really targeted at folks that are building space inside of colocation carriers, somewhere between 5 and 200 cabinets, folks that care about security. From my point of view, everyone should care about security, but there's different levels there. I'm going to briefly talk about these areas. First off, when you build your cage and cabinet, I'd recommend that you think about it from a perspective of a concentric secure enclave, where you have a perimeter with multiple layers inside. It's really trivial to put cameras all around your data center so you can see what's going on. You can run that off-site and store it at another location. One thing we found is it makes a lot of sense to lock the individual doors on the cabinets and cages. I've heard some folks think it's silly to put doors on cabinets if you have a cage. That hasn't been our experience. Key card everything and put door sensors everywhere you can. We have a lockbox where we have certain keys. We have a magnet read sensor on that so we can know when that lockbox is opened. These read switches cost $5. You run them on Cat5 back to a dry contact sensor, and you have great telemetry where things are opened and shut. Certainly they're not foolproof. There's ways to clip the wires and fake them out, but it gives you a really good level of security. And the other big thing is to really audit your logs. Work with your vendor, treat them as your external defense. Ask them to produce logs, videos to show you that they can produce what they say they're doing. Also do that for yourself. It's pretty easy these days to encrypt circuits. When I first started looking at this, I thought I was going to have to build a massive IPsec things. And what I found is that there's a half dozen people in the market today that for 15 grand will sell you a piece of equipment, well, for 7 grand, a piece of equipment that'll do 100 gig line rate encryption. So we found that really helpful. Anything outside the data center we encrypt. When you do that, sometimes you need to be really careful about what kind of spec you give on the circuit, like OTU4E, for example. Little graphic at the bottom right, the router produces a unencrypted circuit, 100 gig, that goes into an OTU4E, 112 gig with framing that does the encryption telemetry, and then you just produce an encrypted line out to your dark fiber or to your lambdas. Encryption key management is really important. I think we've all read in the news about how some of that stuff's been worked around by certain people and groups. Roll your keys periodically, make it a policy. Put your root keys in an HSM. Do two-factor where it makes sense. Probably doesn't make sense with a HSM. Store everything encrypted. It's great that you have an encrypted disk on your laptop. You should also have encrypted files and passwords. Use Shamir's secret sharing scheme when you can for the actual backside propagation of information, and really keep a lookout for any default passwords. Change those immediately. Don't make it something you do later. Encryption at rest is remarkably easy to do these days. Most things we're deploying, and I think a lot of you are deploying, are SSDs. Most SSDs come with SED, self-encrypting disks. It's really trivial to build a system that uses a key escrow system, a secret server that'll be able to pull the discrete keys out to unlock those disks on boot. You're not literally unlocking them, you're literally providing a KEK that's used to unencrypt the MEC to pull the data off. So it's always encrypted, but in this manner it requires an unlock when it's powered on. A little bit of detail here. In some circumstances, it makes sense to encrypt your logical volume or your actual data itself in a database, for example. You have to make your own decisions about the level you want to go to. One thing for folks that are in the kind of product world or the service world, if you think your company might eventually work with the government or any government, you should think really hard about the kind of ciphers and cryptographic protocols you should use, because it's a lot easier to do that right the first time than it is to retrofit it. This is kind of my soapbox stand. I don't know what percent, just for fun, how many folks in the audience work for vendors that sell hardware equipment or software to companies? Yeah, they've all gone home already. So whenever possible, just avoid vendor access. You know, the funny YouTube videos down there, how easy it is to get in somewhere with a ladder, or with a clipboard, or a yellow vest. It's really true. Escort your vendor at all times. Don't trust them out of your site. Don't allow them to handle equipment for you. Just treat them as an advisor, someone that's there to inspect and give you information. That's all I've got. Thanks. I think we got 2 minutes for questions if anyone has any. Matt Petak, Yahoo.
Why, yes, you guessed that correctly. You tossed a little bombshell out there at the start that, you know, we're all moving into the cloud, but in 2 years, we're going to be moving it back out of the cloud. Hey, can you spend half a minute and just tell us why you think everyone's going to move out of the cloud in 2 years?
I'm generally wrong, Matt, so you shouldn't rely on my prognostications. But what I've heard from other people in the industry is that in certain circumstances, companies find that running their own data centers has become bloated through vendor addiction and certain HR policies about people that work in data centers. And they've created a very bloated P&L, and they find that they can shrink that P&L by giving half of that waste to someone like Amazon, Azure, or another vendor. And so I think once they get there, you'll see a bit of an ebbing tide coming back, where they'll say, why are we spending $600 a year for a disk that costs $100, and maybe we should think about cutting our costs.
I'm disappointed. I actually thought it was going to be about security, so I was half hoping you were going to say that there was some deep, dark secret about security in the cloud that meant, from a security perspective, we wanted to pull everything back, but it's just about money. Okay.
Well,
Isn't it always about money?
I think a lot of things are about money in the total cost of ownership, and I'll preface what I'm going to say that I try to be very honest. Never trust a guy who says he's honest. And my book is to preach that cloud security is safe. But I would challenge you to talk about situations where Fortune 500 companies have had significant security problems with Amazon, Azure, Google Compute. Certainly, we've seen tremendous breaches with consumer applications. I'm sure we've seen breaches with enterprise applications as well. But you know, hats off and tremendous kudos to the guys at the big cloud providers who've done a great job with security to now.
Gotcha. Thank you.
Hi, Jake Kuhn, Semantic. So you talked about a lot of the components of a physical security. How about, what are your thoughts on how that gets integrated into an operations level? Does a NOC monitor the physical security? Do they monitor encryption keys for drives or specified encryption keys for drives? Is it a different group? How is that split up from an operations perspective?
So I know of one company that has 4 facets on that. There's a corporate IT security group, which is looking at finding problems. There's another group that's setting policy for how security should be done. And then there's a production operations security team that is doing constant audits, automated audits. So for example, whether you use Ansible or Chef, it's pretty trivial to put a script in that checks to see if a disk's encrypted and flag that if it's not. A lot of the telemetry stuff goes into a simple SEM, so you can watch for things there. I think the implementation of it is really complicated. There's no magic bullet, but it takes a lot of work. And I think what I'm kind of promoting is that you need to think about these things when you build it out, because a lot of them are really easy to do and they're not very expensive. But then how you actually affect that change and implement that policy and run it operationally, I think that's the hard part of operations. I don't think it's ridiculously hard, but every implementation with the culture of the company has to be done differently.
Thank you.
It's Matt Ringel from Akamai. So given that you'll see, as you're saying, if there's a trend to pull stuff back from the cloud, and vendor access is to some extent a reality of the market, do you expect we'll see a swing towards more hardening of hardware, like gyroscopes, or being able to quick weight RAM to avoid against liquid nitrogen attack or things like that?
What was the last one? I didn't hear that.
Injecting liquid nitrogen to freeze the RAM. Any sort of kind of more hardware hardening, TCM kind of thing?
Yeah, that's kind of over my pay grade. I'm scared to death about the fact that my supply chain is potentially vulnerable, and it's hard for me to go in and validate that the precursors to the firmware are what I expect them to be, or that my reliance on signatures is accurate. I want to be unconfrontational, which is difficult for me, but I don't accept that vendors have to have access. There's no vendor that has any sort of access to my stuff. So I realize that in a lot of environments that makes sense, like a lot of disk storage people, bring your disks in and plug them in and tell you when to change them. If that's the risk policy, it's okay, that's fine, but it's certainly not required by us.
Okay, great, thank you.
Thank you. Thanks, guys.
Thank you. Our next speaker is Jeremy Palmer. He's going to talk about automated DDoS protection. Jeremy.
All right. Good afternoon, and welcome to the very last presentation of NANOG 73. Congratulations on you guys for making it this far. All right. So I'm Jeremy Palmer, Senior Backbone Network Engineer for Flexential. And before I get started, I need to thank our VP of Network Strategy, Mr. Tim Parker, since most of you probably already know him, for giving me this opportunity for my very first NANOG talk and coming up with the original idea for the topic. Now, a little bit about Flexential, since I'm sure some of you have never heard of Flexential before. Flexential was created in 2017 with the merger of two first-class data center providers, Peak 10 and BioWest. Altogether, we have 41 data centers and 7 POPs in multiple markets. We have a 100 gigabit based backbone, and I think it's over 3 million square feet of data center footprint. The Flexential backbone network, which is used to connect all of our data center and POP sites together, is 3 terabit per second capacity, over 12,000 route miles, lots of dark fiber, and automated DDoS scrubbing, which is included at no additional charge with our managed bandwidth product. Okay, I'm going to talk a little bit about the steps to mitigate a DDoS attack on the Flexential backbone. And I got to tip my hat to Taylor for his excellent presentation on DDoS and BGP flow spec. Hopefully I don't rehash too much of what he talked about. Step 1, attack detection, because of course you can't mitigate an attack if you don't know about it. There's a couple different ways we can do this. NetFlow-based detection. It's pretty inexpensive and easy to deploy because your border router should already be exporting NetFlow. However, it's a slower detection method, mainly because you have that NetFlow export lag, meaning there's going to be a time delay from when the attack starts to when that flow is exported by the router and detected by your DDoS detection system. Now, packet-based detection can be faster. You're basically looking at that packet flow in real time, but again, it's a more the trade-off is it's a more expensive deployment, a little more involved because you generally have to install dedicated packet sniffers either inline or off of fiber taps with your border routers. Step 2, once we've detected the attack, we need to reroute that attack traffic to somewhere we can deal with it and somewhere we can scrub it. One way we can do this is we can announce a /24, what we call our redirect route, and we announce this out to all our border routers. We use special blocking communities, and I'll go into this a little more in a minute here, but this withdraws any existing /24 prefix from providers that don't do DDoS scrubbing for us. And then, of course, step 3, we need to scrub out that bad traffic, and we need to return the clean traffic to the original destination. We can do this by injecting a /32 scrub route into our scrubbing providers, AS, and then we bring that clean traffic back in through a dedicated DDoS router and circuit. So here we have an example, a basic example network topology. Consists of 3 data center sites, all connected with a high-speed backbone, and all part of the same ASN. In data center A and data center B, we have border routers B1 and B2, which connect to our upstream transit providers. And in data center B, we have customer, and their IP address is 192.0.25. And they are showing red on our monitoring system. And this is because they have a large DDoS attack incoming to their IP address. Our DDoS detector is sitting over here to the right, and it is receiving NetFlow-based or packet-based flow data from our border routers B1 and B2. And so at this point, it's automatically detected that an attack has been launched against our customer. The next thing we need to do is we need to funnel that attack traffic into the AS that's doing our DDoS scrubbing for us. So in this example, we'll say that we've purchased DDoS scrubbing services or managed DDoS mitigation services from AS209 or CenturyLink. Our DDoS detector, utilizing ExaBGP, will inject a redirect route for 192.0.20/24, which contains the IP address that's under attack. And it announces it out to a DDoS route reflector, and this sends it out to all the border routers. Border router 1 receives that route, and it sees that there is a community string for block level 3 in there, and so it effectively withdraws that route, or withdraws that prefix from level 3. The same thing occurs when router B2 receives that redirect route. It sees a blocking community for Telia, and it withdraws that prefix from Telia. At this point, both attack traffic and normal traffic to that /24 are now ingressing through our AS209 transit peers. However, the customer is still red at this point. And so what we got to do now is we need to pull all the traffic in for that one IP address that's under attack into AS209 scrubbing service. So what we've done is, if you look down at data center C at the bottom, we've added what we call a DDoS router, and that has a physical clean traffic circuit back into AS209's scrubbing service. And what our DDoS detector will do, again, using ExaBGP, it will inject the scrub route for the actual /32 IP address that's under attack, and it will tag that with a special community that identifies it as a scrub route. The DDoS router receives that, and it will announce that out to AS209 scrubbing service. And at that point, AS209 has a more specific route for that /32, and so the traffic will now ingress through AS209 scrubbing service. The bad traffic is scrubbed out, the clean traffic is returned over the dedicated clean traffic link to our DDoS router, and it is forwarded, the DDoS router forwards that traffic back into our core, where it can be normally routed back across our backbone to data center B and to the original customer destination. Customer is now green because we have mitigated their DDoS attack, and normal traffic to the rest of that /24 continues to ingress through our normal AS209 transit peers. And it's important to note that step 2, the redirection, and step 3, the attack scrubbing, can really happen at the exact same time. We can look at a BGP route visual to kind of see this in action. And compare a before and after. Now, this is the before we inject that scrub route, or redirect route, I'm sorry. The green dot in the middle is Flex Central, and you can see that this prefix has connectivity to lots of different ASNs going out in all directions. And this is what it's going to look like after we inject that redirect route. You can see that all roads for that prefix now lead to our scrubbing provider's AS, and there's one single path back to the Flex Central, the green dot. So in closing, I just want to point out something that we learned. With DDoS mitigation, one size does not fit all. This method of DDoS redirect that we just went over works best with prefixes originated from your own ASN, and it can also work well for BGP single home customers that announce their own routes to you and use you as transit. Now, downstream customers who BGP multi-home to your network and to, say, another transit provider network need some special consideration. The main thing is if customer connects to you and another network for transit, then of course, depending on how they're announcing their routes, the inbound, or when they do get attacked, the inbound attack traffic could be coming in through one of the other transit providers and could completely bypass your network and your DDoS mitigation system. One other thing we learned with this traffic redirect method is that, and we've learned this in the lab luckily, is customers need to filter their own prefixes inbound, or under certain circumstances, they could learn that redirect route from the other transit provider, and that can cause bad things like routing loops and black holes. It's probably a good idea to filter your own routes inbound anyway. Either way, this type of customer is a very small percentage for us, so it's pretty manageable. And so you guys have learned a little bit about one way we can do DDoS, automated DDoS mitigation on a service provider network. I challenge you to take some of this back and maybe implement it or variations of it to solve some of your DDoS mitigation issues. Any questions?
Matt Petak, Yahoo. Jeremy, great talk, thank you. I'm a little curious taking what you were just talking about here with one of the earlier talks that had the picture of the carpet bomb attack. And one of the assumptions in this is I've got 1/32 that's being attacked, and it's very clear that the 1/32 is being attacked. So the rest of the 24 can just flow normally. Any thoughts on if you do start to see like a carpet bomb style attack where the whole /24 is being hit? Scaling problems with this? Is this the sort of mitigation that's going to work when there's multiple IPs, or is this, well, you can fix one IP or two IPs, but beyond that, it's not going to scale well?
I think that's a good point, yeah. Yeah, and going back to Taylor's presentation, I agree with you. This solution works great for, just a few IPs that are under attack, and this is generally what we've seen in the past with most of our customers. We've been using this solution for a couple years now, and cross the fingers, we've actually never seen any carpet bomb attack. Now, it probably is not going to work that well. I think the biggest problem is, like Taylor was saying, if every source IP is only sending 2 megabits, then your detection system is probably not going to detect that in the first place. So yeah, we are looking at some other solutions right now. We are also looking at BGP flow spec, which is probably not going to solve the carpet bombing problem. But yeah, we're aware that is a weakness of the solution.
Got it. So for any script kiddies that are watching the webcast later, please, 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 no carpet bombing. We don't want that. Thank you.
All right. Thank you for listening.